Okay, now let's do a slightly larger problem, just slightly. Let's try to add, we're still going to add, so step one, add 3 1-bit numbers. Okay, so this is going to kind of push our knowledge of step one. Step two is basically the same. Remember, just kind of making the equations. That will not be any more difficult. And step three will just be a longer circuit, not more difficult. So let's teach the computer. Let me remind you, what does that mean by 3 1-bit numbers? That means now we have 3 numbers. So now we have 0. We have 0 plus 0 plus 1. We have 0 plus 1 plus 0. We have 0 plus 1 plus 1. That's now a 1 0 or a 2. Yeah, I'm sorry, I should be writing these all with 2 digits just to make them the same. We now have 1 plus 0 plus 0, which is 0, 1. We have 1 plus 0 plus 1, which is 2 or 1 0. We have 1, and again, if you're like, I can't remember all these options or patterns or combinations, don't worry, I'll give you a little shortcut here in a moment to help you remember those. 1 plus 1 plus 0 is also 1 0, and 1 plus 1 plus 1 is 3, or 1 1. Remember, 1 plus 1, we have a 1 and a 2, 2 plus 1 is 3. Let's see if I missed one. 1, 2, 3, 4, 5, 6, 7, 8. That's all 8 patterns. So ask yourself a few questions. How many input numbers do I have in my problem? These are the inputs. This is the output. Well, we have 3. So in our circuit, in our truth table, we need an X, a Y, and we'll use Z now. How many do we need in our output? Well, fortunately, we still need 2. So that part of the problem does not get any longer. C and S is all we'll need. Okay, now what will get longer, as you can see, is there's more than 4 combinations. In fact, there's 8. Little trick here mathematically is if there are, we get this because there's 2 to a third. Because there's 3-bit numbers, it's going to be 8, that equals 8. That means you're going to have 1, 2, 3, 4, 5, 6, 7, 8 rows. And we just named them. Now, you may ask yourself, how am I going to remember all 8 combinations? Well, there's 2 basic ways you can do this. The method I prefer is to count to 7 in binary. Okay, so this, now let me stop here because sometimes students get confused. Remember, this is saying X plus Y plus Z. So these are 3 different numbers being added together. However, in order to just remember all the possibilities, I'm going to pretend like this is one number and then just count to 7. So this is not one number, but I'm going to pretend it is just so I can remember all my digits. 1, 2, 3, 4, 5, 6, 7. Now, let's say you say, I can't remember, or I can't count like that. Okay, worst case, remember in the last couple of videos I said, I'd love for you to understand, but if not, if you can just do these steps, here's just the, if all else fails, do these steps. Look at the pattern. In the first column, 0, 1, 0, 1, 0, 1, 0, 1. In the next column, 0, 0, 1, 1, 0, 0, 1, 1. In the third column, 0, 0, 0, 1, 1, 1. As long as you can remember those 8, then if you can just write that out every time, you'll get it right. So I prefer that you counted because that just reiterates the concept of binary. But again, worst case, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. Third column, 0, 0, 0, 0, 1, 1, 1, 1. There's a pattern there. Okay? Now let's teach the computer the answer. 0 plus 0 plus 0. And again, this is just a repeat of these numbers up here. The answer to this problem is 0, 0, 0, 1, 0, 1, 1. I know I'm going fast, but this is just adding 1 plus 1. This is adding 0 plus 1 plus 1 is 2. 1 plus 0 plus 0 is 1. 1 plus 0 plus 1 is 2. 1 plus 1 plus 0 is 2. 1 plus 1 plus 1, 3. Okay? Now, let's make some equations. And yes, as you can imagine, the equations will become a little longer because it doesn't really matter which order you do these in. Okay. Again, but here's the nice thing. No new concepts. Just do the same thing we did before. Go down the C column first, and if you see a 0, skip over it. So don't care, don't care, don't care. We do care. Every one of these will be X, Y, and Z, and this one has a line over the X. Don't care, we do care. In fact, we care about the last 3. So the last 3, so or X, Y, Z, and we have a line over the Y, or X, Y, Z, we have a line over the Z, or X, Y, Z, and no lines, because they're all zeros. Again, I'm going over that fast, but that's a repeat of, I think, the first and second videos that since we started these circuits. S, let's go down the S column. Don't care, I do care. So we write, excuse me, X, Y, Z, X, Y, Z, and we have a line over both X and Y. Or, that's a plus. Let's see, we do care, so we have a X, Y, Z line over both the X and the Z. Or, let's see, we don't care, we do care. X, Y, Z lines over the Y and the Z. Remember, these lines represent knots, which we'll put the little triangles in on the circuit. And lastly, we don't care, we don't care, we do care, and it's X, Y, Z as well. Now, the fact that we have the same one in both X, Y, Z, simply means that when all of those are 1s, we want 1 for both equations. And see, that's what we want. We want a C to be 1 and an S to be 1. So that's all that means. Okay, now for the fun part, in my opinion. Let's make a bus. And now I think I can actually make a better bus because I can make a straight line. Now I'm going to zoom out just for a second here. Hopefully I won't draw that line there. Okay, it's not zooming out. Ah, here's why. Okay. And what I'm going to do is I'm going to make my canvas longer because, as you can guess, circuits that have more pieces to them become longer. So hopefully this is enough. Let's make 3 lines. Line 1. This is our bus. Remember, a bus is a highway of wires running side by side. Okay, good enough. Okay, and let's label this X, Y, and Z. All right, let me zoom back in so you can see a little bit better. That's probably a little too far out. Okay, can you see that? All right, well, we're also going to see our equation at the same time, so let's see if we can see both here. Okay, we'll do C first. I don't care which one you do first. To move that guy out of the way. All right, so as you can tell, this is going to get a little bit longer, but that's okay. We have 4 kind of expressions to work with. Every one of these is going to be an X. Oops, my pen tool. Every one of these will be an X, a Y, and a Z, and then something will happen to one or more of the, they'll be inverted. And they all end in an AND. Okay, so this first one, the knot is on the, wow, this is getting messy, on the X, and nothing happens to Y and Z. Those have ANDs. Does that make sense? So that's not X and Y and Z. Not X and Y and Z. Okay, or, let's pull out another 3. This time the X goes straight, but the Y is inverted, and the Z is not. So we combine those with an AND. Let's see, we've got this one right here now. We have X, Y, Z again. You'll always have all 3 letters. And this one, the Z is inverted. And then lastly, X, Y, and Z, no knots, no inverting. So just pull all three of them across. Kind of messy, but now how are these combined? Now don't do what some students do, and they make a massive OR sign. That's just messy. So let me show what I prefer. Take these outputs, run them all together so they're all in a reasonable amount of space like that, and then draw our curve, and then our squiggly shaped shield, which is OR, and label that C, so we'll know that's C. Okay, so yes, it's a little longer than just the one we did in the last video, but same concepts. You can see how once you're at this step, once you're at the equation step, it's pretty easy just to convert this into a circuit. X, Y, and Z again, use the same bus, X, Y, and Z. Now this one, we have two knots in each one, so this may be a little messier for me with this pen. So that's X, Y, and then Z. Again, and let's see, the X and the Y, so X, not, Y straight, Z is not. Again, and let's see, that was that one right there. Now we have this one, it's the last two. So we have X doesn't have anything. Oops, that went crooked. We have Y and we have Z. And then finally we have XYZ with no knots, so to speak. Sounds like a rope without knots. And we'll just, so no knots. And we have tie these together so it's a little nice and neat. How does all these combine with ORs? In other words, I want S to be true if this is true, or this is true, or this is true, or this is true. So we combine, whoops, we combine, that is really messy, but I don't want to start over at this point. That's really bad, but that's what letter, that's a S. That is what you'll turn in for your homework. Well, and the circuit and the truth table. But that, and again, before I stop here, just remind you, these are actual wires, very, very tiny wires, but you could build this with very large wires if you want to build one yourself. And these are made with transistors. So literally by sending voltage down some of these wires, but not others, we can create a value. Let's say if I want to say 0 plus 1 plus 1, I could send that through all these circuits, and let's see, a carry would come out true at the very end, and this would come out to be a 0, because 0 plus 1 is 1 in the C wire, and 0 is the S wire. You can think of these as wires as well. And these would eventually get turned back into, let's say, the monitor would actually display the number, 1 or 2 or 9, but in the very heart of the CPU, it's just ones and zeros going down these wires and storing these wires. So that is a 3-bit 1-bit adding machine or circuit. And we're going to continue this and build upon this probably one more video, and hopefully that'll wrap up these circuit videos.